Welcome to lesson 9.6, Applications of Linear Inequalities. This is Miss Fleming, and this is actually a chapter 9 lesson, but as you know, we went on spring break, so we didn't include this in the chapter 9 test. So we pick it up here. There's also lesson 9.6, which is going to be linear systems of inequalities. All right, so let's review a little bit. Take a look here, and these are my alligators. So, inequalities, instead of having equal signs, we are going to have inequality symbols. So, no equal signs. Less than opens this way. Keywords, fewer than, under. There's going to be many other keywords, but this is what we're going to be looking at in the word problems. Okay, this alligator is greater than. So, fewer than, the opposite of that would be more than. The opposite of under is over, exceeds, does not exceed, could be any of those things. All right, less than or equal to. No more than, maximum. Could be fewer than. This one is greater than or equal to. At least, up to, or minimum. Don't try and memorize these. When we start reading the word problems, all of that's going to make sense. Then we get into what do the graphs look like? Okay, well, these are linear. They're going to graph on ordered planes or on coordinate planes. So if it is a less than, we're going to have a dashed line and we're going to shade below. So to recall what that looks like, let's draw a couple of graphs. So just a couple of these for now, and then we'll put some shading in. Oh, I wish I could draw a straight line. Let's see if I can do a little better. I'm drawing X and Y's axis, not crazy T's. I'll get better at the end, right? Maybe. All right, I'm doing two because above could be in two directions, and I want you to see the distinction. Okay, so let's take a look at this. All right, we are going to have a dashed line and we're going to shade below. So we could have a dashed line that was positive. The slope is increasing. And this way is above, this way is below. So I'm going to draw an arrow down there so you can clearly see where below is. And when I shade this, I want to shade it very carefully so that I can see underneath it. Okay, so let's say I was going to do a slope with a negative or a negative line. This one is dashed. This time, this is above. This time below is this way. You've seen this before. We saw it at the end of the first semester, but we're reviewing it in case you don't remember. Then I shade in all of that region. Okay, so greater than, and this is still going to be a dashed line, but this time the shading is above. So again, let's do one with a positive slope. And above is going to be this direction. And I would shade all of this region in. Okay, this is dashed, and this time we'll do it with a negative slope. Dash line, and this time above is this way. And I would shade all of this in. All right, this time the line is going to be solid and the shading is below. At this point you are remembering, I hope. So let's do one with a positive slope. It's a solid line. And it is below, so the shading is this way. And it would be very carefully moved in that way. Okay, let's do one with a negative slope. Above is this way, below is this way. Shade this side. Okay, again, we've got or equal to, so we're going to do a solid line. Here's a positive slope. And below is this way, so above must be this way. And we're going to shade this in. And here's my negative slope. Below and above. Now, you're not going to do any graphing today. You're going to be looking at graphs and determining which one is correct. So you won't have to watch me do this painful graphing anymore. All right, so here's my alligator again. This time he's giving you a clue. Find and underline the phrase for the inequality. And let's page down. I don't want to move that, I want to scroll. Okay. All right, the first set of problems are going to be in slope-intercept form. The second set, let's put it this way since I don't have to scroll as much. The second set are going to be in standard form. So y is equal to mx plus b, but this is a box because we're not putting an equal sign. All right, x is going to be my input. That's my independent variable. M is still going to be my slope. And these are word problems. So m is going to be the rate of change. So we're looking for words that say per each and every. And b is my y-intercept, so it's my initial value. Where did I start? What did I do only one time, like pay a flat fee? Now, for these problems, we're only going to be defining one variable, and that variable is going to be the independent variable's x. We're going to be given an amount for y. Okay, well, this says this plus this would be equal to this. That makes y, in this case, a total. So we're going to be looking for a rate of change, an initial value, a total, a phrase that tells us what our inequality should look like, and we got to define a variable. That sounds like a lot, but it's really not that hard. Okay. Yellow Cab taxi charges a $2.25 flat rate in addition to 75 cents per mile. All right, I already know I've got a per word here. Okay, so that tells me that 75 cents is going to be my rate of change. And I've got a $2.25 flat rate. Flat rate is something I'm going to pay once and only once. That's going to be my initial value. This gets charged over and over for every mile. I pay this one time. Kate has no more than $30 to spend on the fare. So that is going to be my total. In addition to that, I have found my inequality phrase. That's the word total. Okay, so let's go back and change colors. Let's put that in the flashy green. She has no more than $30. So I can spend $30. I can spend less than $30, but I cannot spend greater than $30. What I need to do now is define a variable. Well, this tells me what I'm putting into this is I'm going to put the number of miles in, and I'm going to get out what my cab fare charge is going to be, which is my total of $30. So in this case, x is going to equal the number of miles. Okay, and here's my equation. So I put the total here. So I've got $30. I'm going to leave a space where I'm going to put my inequality. My rate of change is 75 cents. So I've got 0.75 times the number of miles. And then I'm going to add in my initial value, which is my flat fee, which is $2.25. All right, so what are we going to put here? It says this side is going to be $30. This side has got to be less than or equal to $30. It cannot be more than $30. So we're going to go ahead and put a less than or equal to. If you read it like that, it's pretty easy. Can't go over 30. This has to be less than or equal to 30. All right, what are we going to do now? Well, we're going to solve for x, just like we would solve any equation. So we're going to subtract $2.25 from each side. And this is going to be a two-step equation. After I do that, I've got $27.75. And that's still this. And so what am I going to do? I am going to divide both sides by 0.75. And after I do that, I'm going to have x is going to be equal to, actually not equal to at all. It's going to be, and let's not turn it around because that'll confuse you. I'll turn it around in just a second. Okay, this side that is greater than or equal to x is now 37. All right, so what does that say? That says that I want, how far can she ride? No more than 37 miles. Okay, that was simple enough. So the wording, oh, did you hear that crash? That was my soda knocking on the door. All right, back. So the wording for the answer came exactly from the inequality phrase. There's my 37. I was solving for number of miles. That was pretty straightforward. That was not difficult. Okay, I've got two more examples, and then we've got some graphs. Okay, your high school band, marching band, high school band is having a fundraiser selling boxes of Krispy Kreme donuts in order to purchase new marching uniforms. They spent $3,500 advertising the fundraiser, and they make $1.75 per box sold. How many boxes do they need to sell in order to at least break even? Okay, at least has got to be my inequality. What does break even mean? I spent $3,500. That's already out of pocket. So I can't even make a profit for my fundraiser until I make this $3,500 back. That's what the break even is. So at this point, this is clearly a rate of change because I've got a per. So that's going to be an M. Okay, this is not an initial value. This is the amount that I've got to recover, I've got to break even with. So that's actually going to be a total. So I don't have an initial value. I want to find out how many boxes of donuts I have to sell to make that much so that I break even. All right, so what is X going to be? I'm going to answer the question. How many boxes do they need to sell? So X is going to be the number of boxes. It's not the number of donuts, it's the number of boxes. Okay? Now remember, we're doing these in slope-intercept forms, so I'm going to put I've got a Y on this side, which we said is a total, so there's my $3,500. On this side, I've got the rate of change with the variable. And now I need to figure out what at least means. Okay, so I want to make this, but I'd be happy if I made more than that. So I want this side to be greater than or equal to this. At least tells me that. Okay, you can write them the other way around, it doesn't matter, but this side I want to be equal to 3,500 or more than 3,500. So this side is greater than or equal to. I have one step here. I'm going to divide by $1.75. And that's going to tell me how many boxes I need to sell. So on this side, I've got 2,000 is less than or equal to X. So my answer says that I need to sell at least, which came right from there. That's an at 2,000 boxes. Okay. Now, you might be more comfortable putting the Y on the other side, so let's do that for the next one. Kate practices the violin a minimum of 12 hours per week. Okay, there's a dead giveaway right there. A minimum is going to give me an inequality. 12 hours per week, there's a per, so I've got a rate of change right there. She practices for 3/4 of an hour each session. Okay, well that's interesting. Not a full hour, 3/4 of an hour. So let's think about what we're going to do with that. And Kate has already practiced 3 hours in 1 week. How many sessions remain to meet or exceed her weekly practice goal? Okay, that's interesting too. So there's a lot of words in this one. But I know I need number of sessions because that's the question to answer. She's already practiced for 3 hours in 1 week. How many sessions? So our variable is going to be number of sessions. Regardless of what else is going on, I'm going to answer the question with my variable. All right, so what are we going to use? We have a minimum of 12 hours, so I know I've got a total of 12. Let's put that over here. So this was not the rate of change at all. This is, in fact, the total. So let's cross that out and erase it. 12 hours, this per just means 12 hours in that week. That's the total we're chasing. So let's change that. So now I'm looking for another rate of change that has to do with sessions. And that's going to be right there, each. Each session is 3/4 of an hour. Okay? So, 3/4 is going to give me, and the number of sessions is going to give me how many hours I need on this side. And I have an initial value because she already did 3 hours. So I'm going to go ahead and put 3 hours there. And what am I going to put here? Okay, we need to meet or exceed. So we can do exactly 12 hours. Exceed means we have to do more than 12 hours. So this is going to be greater than or equal to. This part's the easy part. Okay, now we're going to go ahead and solve this. I could also put 0.75 here. If you recognize that 3/4 is 0.75, you could have done that. But I'm going to go ahead and use the 3/4 because I want you to do some equation stuff here. So minus 3. And I've got 3/4 x is greater than or equal to 9. Okay, this is division. That says 3 divided by 4. So how do I undo division? I multiply. So I'm going to multiply both sides by 4. And this multiplication is going to cancel out that division. So now I've got 3x is greater than or equal to 4 times 9, which is 36. And divide everything by 3. That tells me x is greater than or equal to, I have the wrong answer. Okay, 12. All right, so answer my question. How many sessions? She needs 12 sessions to meet or exceed. And you could put something there, oh, it's a practice goal, her goal. I don't necessarily need full sentences as long as you know that that's what the answer is. Yeah, that's interesting. All right, one more page. This time we're going to take a look at some graphs. page 2? Maybe not. Oh, it's right here. All right, here's page 2. All right, this side of the page, we're going to do the inequalities. They're still in linear form, but this time it's standard form. So ax plus by, and we're not going to have an equal. We're going to have a greater than, less than, whatever it is, and c. All right, a and b are both rates of change. So you remember this from when we did systems. Those are both going to be rates of change, and c is going to be a total. X and y are both going to be variables, so we're going to have 2 this time. And let's go ahead and scroll this. See, look, you don't have to draw the graphs. I give them to you. You might not like that any better, though. At a clothing store, t-shirts cost $20 and skirts cost $25. If the store wants to sell at least, I don't know why I've got an apostrophe S there, $600 worth of t-shirts and skirts, write an inequality representing the possible combinations of t-shirts and skirts that should be sold to meet this goal. Wow, that's poorly written, and I wrote this. Sorry about that. All right, so right there, I've got a cost for a t-shirt, I've got a cost for a skirt, and I've got $600. So I'm thinking that this is going to be a total. This is going to be a rate of change because for every shirt or skirt I buy, they are $25 per skirt. T-shirts are going to be $20 per t-shirt. So those are rates of change. The questions I have to answer are, we need combinations of t-shirts and skirts. So we're going to say that X is the number of t-shirts. And Y is going to be the number of skirts. All right, so right now I know that a t-shirt is $20, so 20x plus a skirt is $25. And there's going to be some kind of inequality, and I've got a total of 600 right here. All right, let's go find our phrase that says what our inequality is going to be. It's really straightforward. It's right there, at least. Okay, so I am happy to make $600, so I'm going to have an or equal to there. But I really like to make more than that. So at least 600 says that this side I really want to be greater than $600. That's pretty straightforward. All right, so what are we going to do? Well, look at these. What we need to do is solve this equation for y so that we can figure out which one of these graphs match that equation. Okay, so let's switch back to blue. First thing, I'm going to solve for y, so I'm going to subtract 20 from both sides, 20x. Two-step equations. And I'm funny, I like my slope to be in front. So that's going to give me 25y is greater than or equal to, I'm going to put the slope in the front, plus 600. And then I'm going to divide by 25. And that's going to say my slope-intercept inequality is going to be y is greater than, and we have to reduce the fractions. You always have to reduce the fraction for the slope. So 4/5 x plus 24. All right, and that's a negative 4/5 x. All right. So no help there because these all have a negative slope. As x is increasing, the y is decreasing. There's no help there. All right, I can start with this though. Let's go ahead and find out if we can eliminate anything that doesn't have an x-intercept of 24. Okay, well this one's got an x-intercept of 30. This one's got an x-intercept of 30. So I know already that that's not going to work. Okay, they're both solid lines, so that's not any help. But look at this one. This is above, that one is below. Okay, so the y-intercept would knock these two out because I needed 24. 24 is going to be between 20 and 30, so it's got to be one of these two. This says greater than or equal to. I've got solid lines for both of them. Let's look that down, just in case I had a dash line in one of them. And that's greater than, so my shading is going to be above. Okay, that is below, that is above. So that's knocked out because that's below. This one is above. And let's see if we can find anything to just reinforce that. No, I don't have to. That's enough. Negative slope, solid line, shading above. That's plenty. Okay, one more example. Same thing, we're doing a standard form. At a bookstore, books are sold for $15. The store purchases new books with the money they make. Which, I need to really read these. These are grammatically horrible. The store purchases new books with the money they make, which each cost $10. So new books are $10. They sell books for $15. If the store wants to make at least $1,000, write an inequality representing all the possible combinations of the sold books and the new books. Okay, well, I'm going to answer the question, and I need a combination of sold books and new books. So X is going to be the number of books sold. And Y is going to be the number that are new. All right, I've got a cost here and I've got a cost here, so these are going to be my rates of change. And sold books are $15. So 15x, and I am selling books and I am buying books. So this time, that 10 is going to be negative. That's going away. And I want to make at least $1,000. So $1,000 on this side. I'd settle for $1,000, but if I made more than $1,000, I'd be even happier. So this side needs to be greater than or equal to $1,000. And I forgot to put the graph number in the one up above, so make sure you put D on the one up above. All right, so we're going to solve this one for Y. So let's go ahead and subtract 15 from both sides, 15x. And I've got negative 10y is greater than or equal to, and I'm going to put the slope in the front because that's how I like it, plus 100, 1,000, excuse me. All right, now we're going to divide by negative 10. What happens when that's interesting. What happens on an inequality when I divide everything by a negative? That's going to reverse. So dividing through by a negative, this goes this way. And this is now positive. So my slope is now going to be 3/2 x. And this is 1,000 divided by negative 10. So this is now going to be negative 100. All right, so let's go find our correct graph. First of all, let's go ahead and see if we can find a negative 10. And that's a problem because that's down here somewhere. We can't see the y-intercept. All right, so we've still got solid lines. They're all solid. but we've got less than, so we're going to be solid and below. So let's at least eliminate some that way. All right, this one's below. This one is above. Get rid of that one. That one's below. This one is above. So we're going to get rid of that one. All right, so now we're going to follow up on our slopes. And I've got up 3 over 2. Let's see if we can find that somewhere. Okay. All right. 1, 2 over 3. So that doesn't look very promising. And this one, let's go from, that looks like a grid point. So 1, 2, 3, 1, 2. That one's up 3 over 2. So the correct answer is C. All right. So that is the end of this lesson. So you've got some that are going to be in slope-intercept form. You've got some that are going to be in standard form. And you're going to have to do some matching of graphs based on the information you have at hand. End of the lesson. Have a great day.